Am I audible to all of you? Just write in the chat box. Okay. So now I am sharing my today's presentation slides. Just a minute. So in the last class, we already completed the cache memory, and now in today's class, we are going to start a new topic, which is virtual memory. So first, we will going to see the introduction of virtual memory. So as its name suggests that this memory is not real. That's why its name is virtual. So virtual memory is a storage mechanism which offers user an illusion of having a very big main memory. So this memory is not actually present, but it gives the user or the programmer the illusion that the programmer is having a very big main memory. So it is done by treating a part of secondary memory as the main memory. So in the case of virtual memory, we are treating the part of secondary memory as our main memory. In virtual memory, the user can store processes which is bigger size than the available main memory. So its definition is very important because this memory is not actually exist. That's why its name is virtual. But we need to take the part of secondary memory as the main memory in the case of virtual memory. So in order to store bigger processes than the size of the main memory, so therefore instead of loading one long process in the main memory, the operating system, which is abbreviated as OS in the short form, the operating system loads the various parts of more than one process in the main memory. So we are by dealing we already see when we are discussing the cache memory, in the physical memory, the operating system stores many frames of the process or different processes. So virtual memory is mostly implemented with demand paging or demand segmentation. So these are the two popular techniques by which we can implement the virtual memory. So all of you understand it? Just write in the chat box so that we can move further. Aditi, Jaya, and all of you understand it? Just write in the chat box so that we can move further. Okay. So moving to the next slide. So virtual memory is the separation of logical memory from the physical memory. So as you can know that the logical memory is generated by the CPU. The CPU generate the logical addresses, or the logical memory is generated by CPU, and the physical memory is generated by the or physical memory or the main memory is same, and it is generated by RAM, by random access memory. So this separation provides large virtual memory for programmers when only a small physical memory is available. So the major task of virtual memory is to give illusion to the programmer that they have a large portion of physical memory available for them. So virtual memory is used to give programmers the illusion that they have a very large memory, even though the computer has a small main memory. So it makes the task of programming easier because the programmer no longer needs to worry about the amount of physical memory available. So, but this is the advantage of virtual memory. It gives the programmer the illusion that it has very large physical memory available with him. So the programmer need not to consider about the memory. It's just considering the program. So moving to the next slide. So why virtual memory is needed? So whenever our computer does not have space in the physical memory, it writes what it needs to remember to the hard disk in the swap file as virtual memory. So if a computer running Windows means Windows operating system needs more memory oblique RAM memory then installed in the system. Suppose your RAM is of 4 GB size and you required more than 4 GB for running the program, then it uses a small portion of the hard drive for this purpose. So that concept in that situation the virtual memory concept is used. So in that situation we needed the virtual memory. So moving to the next slide. Now comes the question how virtual memory works. So in the modern world, virtual memory has become a quite common these days. It is used whenever some pages require to be loaded in the main memory for the execution and the memory is not available for those many pages. So you you remember that virtual memory only needed when the main memory is insufficient in order to execute the program. In that case we need a virtual memory. So in that case, instead of preventing pages from entering in the main memory, the operating system searches for the RAM space. So basically it is the task of the operating system. So operating system searches the RAM space that are minimum used in the recent times or that are not referenced into the secondary memory. So operating system searches that memory location which is free. So in order to allocate that memory location to the virtual memory to make the space for the new pages in the main memory. So it is the task of the operating system to find out which pages are vacant and those pages are being assigned new pages in the main memory. So all of you understand it? Just write in the chat box so that we can move further. Okay. So moving to the next slide. So as an example, let us assume that an operating system requires 300 MB of memory. So this is given to us that operating system requires 300 MB of memory to store all the running programs. However, there's currently only 50 MB of available physical memory stored on the RAM, but RAM is having only 50 MB available with him. So the operating system then set up 250 MB is less. So 250 MB of memory of virtual memory and use a program called Virtual Memory Manager, which is abbreviated as VMM, Virtual Memory Manager, to manage that 250 MB. because 250 MB is required for RAM to run the program. So in this case, the virtual memory manager will create a file on the hard disk that is 250 MB in size to store extra memory that is required, as the RAM required 250 MB in order to run the program. The operating system will now proceed to address memory as it considers 300 MB of real memory stored in the RAM. So even if only 50 MB space is available in the RAM, it is the job of the virtual memory manager to manage 300 MB memory even if just 50 MB of real memory space is available with the RAM. So this is the example of working of virtual memory. So whenever you asked the question that how a virtual memory works, so you can write the theory part as well as given the example also. So that's how the virtual memory works. So I am sharing a small video with you in order to understand the concept of virtual memory in a much more or better way. So I am sharing that video with you. Just a minute. So just the difference that the virtual memory is what the program sees, and the physical memory is the physical RAM in the computer. So just concentrate what is been delivered in the video lecture. So all of you understand it till now? Just write in the chat box. Okay. So moving to the now, just continuing the video. Just concentrate on it. just concentrate here that uh, virtual address is basically the address generated by the CPU, which is the processor. So this address is generated by the CPU, and the main memory address, which is known as the physical memory address, is generated by the RAM. So basically here we are translating the virtual address to the physical address. So just to see or that how we are going to translate the virtual address to the physical address. So this part is very important, just concentrate on it. Just concentrate here that here we fi- we are going to find the virtual address 1024, and uh, in the mapping table or in the page table, it is translated to the second physical address, because the address starts from 0. So it is the 0th position, it is the first position, and it is the second position. So it maps to the physical address 2. So now as we find the data in the physical address, so we need to move that data to the processor. So by this line we are, or by this arrow we are moving uh, the physical address to the virtual address, right? Just now continuing the video. Just to concentrate here that in this case, when we are going to find the address, the physical address for the virtual address 786, then it is not found in the physical address. So uh, we are we will going to search in the disk, and here we already, once we find that address in the disk, then we need to move that address to the physical memory. And now we are going to update that information of the physical memory into the table, or the translation table, which is known as the page table. So all of you understand it till now? Just write in the chat box. If we find it in the physical memory, then it's okay, we need to translate, or we need to transfer it into the to the CPU. But if we not find it, we are going to find it, then we need to move to the disk, and after that we can uh, place the data from the disk to the physical memory, and then we need to update the table as well. So just write in the chat box so that we can move further. Okay. So just remember these four steps. How does the program access memory in the case of virtual memory? So you need to just remember these four steps. The first, the program executes a load with a virtual address. Then computer translate the address into the physical address in memory. Then if the physical address is not in the memory, then operating system loads it in from the disk. And the fourth step is the computer then reads the RAM using the physical address and returns the data to the program. So you need to remember these four steps. So now continue in the video. So So that is the concept we already studied in the video previously. So we need to convert the virtual address into the physical address. So a question is being given to you, and you need to convert that virtual address into the physical address by doing the mapping. Means that this mapping, the translation, the mapping from the virtual address to the physical address. So as you can see from this example that the mapping table shows that the virtual address 1536 is present in the disk. So it can only be shown in the disk when this virtual address is not available in the physical memory. Only then it shows that virtual address is available in the disk. So all of you understand it till now? Just write in the chat box. So here the question is basically if a program, you can see it clearly, if a program uses more data that then can fit into the RAM, it means that the RAM size is less and you need to fill or fit more data than the RAM. Then where does the data go? Obviously, the RAM size is less and the hard disk size is more. So basically, if we need to uh, place more data than the RAM size, then the extra data will be stored in the disk. So that's what it is shown in the in this example, that if a virtual address, we need to find a virtual address 1536. So basically our mapping, from the mapping table we need to convert the virtual address into the physical address. So we need to search that 1536 into the physical address table, but here in the mapping table it is given that 1536 is basically in the disk. So it means that 1536 virtual address is not present in the physical address. So it presents in the disk basically. So we can as we seen in this video previously or earlier, that if the data is present in the disk, then we need to to fetch that data from the disk, and we can load that data into that physical address, and from there we can translate the physical address into the CPU. So that's what it is shown in this example. So now you understand it. Okay. So I think in today's class we went. So I think we should stop today's class till here, because there are not many, I think, participants are there. So we will continue this topic in the next class. So thank you very much. The recording of this video lecture uh, will be available in the college YouTube channel from Monday onwards. Okay, thank you very much. Now you can leave this meeting.